A binary code represents text or computer processor instructions using the binary number system's two binary digits, 0 and 1. A binary code assigns a bit string to each symbol or instruction. For example, a binary string of 8 binary digits can represent any of 256 possible values and can therefore correspond to a variety of different symbols, letters or instructions. In computing and telecommunication, binary codes are used for various methods of encoding data, such as character strings, into bit strings. Those methods may use fixed-width or variable-width strings. In a fixed-width binary code, each letter, digit, or other character is represented by a bit string of the same length. That bit string, interpreted as a binary number, is usually displayed in code tables in octal, decimal or hexadecimal notation. There are many character sets and many character encodings for them. A bit string, interpreted as a binary number, can be translated into a decimal number. For example, the lowercase a, if represented by the bit string 01100001, can also be represented as the decimal number 97. History of binary code. The modern binary number system, the basis for binary code, was discovered by Gottfried Leibniz in 1679 and appears in his article Explication de l'arithmétique binaire. The full title is translated into English as The Explanation of the Binary Arithmetic, which uses only the characters 1 and 0, with some remarks on its usefulness, and on the light it throws on the ancient Chinese figures of Fu Zai. Leibniz's system uses 0 and 1, like the modern binary numeral system. Leibniz encountered the Yijing through French Jesuit Joachim Bouvet and noted with fascination how its hexagrams correspond to the binary numbers from 0 to 111,111, and concluded that this mapping was evidence of major Chinese accomplishments in the sort of philosophical mathematics he admired. Leibniz saw the hexagrams as an affirmation of the universality of his own religious beliefs. Binary numerals were central to Leibniz's theology. He believed that binary numbers were symbolic of the Christian idea of creatio ex nihilo or creation out of nothing. Leibniz was trying to find a system that converts logic a unregistered trademark S verbal statements into a pure mathematical one. After his ideas were ignored, he came across a classic Chinese text called a I Ching, a unregistered trademark, or a book of changes, a unregistered trademark, which used a type of binary code. The book had confirmed his theory that life could be simplified or reduced down to a series of straightforward propositions. He created a system consisting of rows of zeros and ones. During this time period, Leibniz had not yet found a use for this system. Binary systems predating Leibniz also existed in the ancient world. The aforementioned I Ching that Leibniz encountered dates from the 9th century BC in China. The binary system of the I Ching, a text for divination, is based on the duality of yin and yang. Slit drums with binary tones are used to encode messages across Africa and Asia. The Indian scholar Pingla developed a binary system for describing prosody in his Chandashutram. The residents of the island of Mangarval in French Polynesia were using a hybrid binary decimal system before 1450. In the 11th century, scholar and philosopher Shoyong developed a method for arranging the hexagrams which corresponds, albeit unintentionally, to the sequence 0 to 63, as represented in binary, with yin as 0, yang as 1 and the least significant bit on top. The ordering is also the lexicographical order on sextuples of elements chosen from a two-element set. In 1605, Francis Bacon discussed a system whereby letters of the alphabet could be reduced to sequences of binary digits, which could then be encoded as scarcely visible variations in the font in any random text. Importantly for the general theory of binary encoding, he added that this method could be used with any objects at all, provided those objects be capable of a twofold difference only. As by bells, by trumpets, by lights and torches, by the report of muskets, and any instruments of like nature. Another mathematician and philosopher by the name of George Boole published a paper in 1847 called The Mathematical Analysis of Logic that describes an algebraic system of logic, now known as Boolean algebra. Boolean unregistered trademark S system was based on binary, a yes-no, on-off approach that consisted the three most basic operations, and, or, and not. This system was not put into use until a graduate student from Massachusetts Institute of Technology by the name of Claude Shannon noticed that the Boolean algebra he learned was similar to an electric circuit. Shannon wrote his thesis in 1937, which implemented his findings. Shannon's thesis became a starting point for the use of the binary code in practical applications such as computers, electric circuits, and more. Other forms of binary code. The bit string is not the only type of binary code. A binary system in general is any system that allows only two choices such as a switch in an electronic system or a simple true or false test. Braille. Braille is a type of binary code that is widely used by blind people to read and write. This system consists of 6 dot positions, 3 in each column. Each dot has 2 states, raised or not raised. Bagua. The Bagua are diagrams used in Feng Shui, Taoist cosmology and I Ching studies. The Ba Gui consists of 8 trigrams. Ba meaning 8 and Gui meaning divination figure. The same word is used for the 64 Gui. Each figure combines 3 lines that are either broken or unbroken. The relationships between the trigrams are represented in 2 arrangements, the primordial, earlier heaven, or Fui Bagua, and the manifested, later heaven, or Kingwen Bagua, Ifa divination. Ifa is the ancient system of divination and literary corpus of the Yoruba people of Nigeria. In Yoruba religion, the rite provides a means of communication with spiritual divinity. The Oriza Ifa or Orunmila permits access to an initiated priest, a Babalawo who generates binary values using sacred palm nuts. In wood powder, these are recorded as single and double lines. There are 16 principal oda that are said to compose the 256 oda. From memory alone, a Babalawo must be able to recite 4 to 10 verses for each of the 256 oda Ifa, generally, Oriza law, traditional medicine, and ritual advice. In 2005, UNESCO listed Ifa in the masterpieces of the oral and intangible heritage of humanity. Morse code. Morse code is a method of transmitting text information as a series of on-off tones, lights, or clicks. Any Boolean system such as this, which encodes meaning, is a form of binary code. Coding systems. Ascii Code, the American Standard Code for Information Interchange, uses a 7-bit binary code to represent text and other characters within computers, communications equipment, and other devices. Each letter or symbol is assigned a number from 0 to 127. For example, lowercase a is represented by 1,100,001 as a bit string. Binary coded decimal, or BCD, is a binary encoded representation of integer values that uses a 4-bit nibble to encode decimal digits. 4 binary bits can encode up to 16 distinct values. But, in BCD encoded numbers, only the first 10 values in each nibble are legal, and encode the decimal digits 0 through 9. The remaining 6 values are illegal, and may cause either a machine exception or unspecified behavior, depending on the computer implementation of BCD arithmetic. BCD arithmetic is sometimes preferred to floating-point numeric formats in commercial and financial applications where the complex rounding behaviors of floating-point numbers is inappropriate. Early uses of binary codes. 1875, a Permel Bordot edition of binary strings in his ciphering system, which, eventually, lead to the ASCII of today. 1884, the linotype machine where the matrices are sorted to their corresponding channels after use by a binary-coded slide rail. 1932, C. Ewing-Williams scale of 2 counter. 1937, Alan Turing electromechanical binary multiplier. 1937, George Stibitz XS3 code in the complex computer. 1937, Atanasoff Berry computer. 1938, Konrad Zuse Z1. Current uses of binary. Many things besides computers use binary, such as CDs, which have a series of hills and valleys on the surface. These either reflect the light of the thin laser beam shone on them, representing a 1, or do not, representing a 0. However, these hills and valleys do not directly represent user-accessible data bits. This media-level signal is decoded into 14-bit words that are further decoded into 8-bit bytes of user data by a lookup table. The 8 to 14 encoding is done to prevent long runs of ones or zeros at media levels so that the signal won't be susceptible to sync drift and dropouts. Weight of binary codes. The weight of a binary code, as defined in the table of constant weight codes, is the Hamming weight of the binary words coding for the represented words or sequences. See also, binary number, list of binary codes, binary file, Unicode, gray code, notes. External links, Westerstein, Eric W., Error Correcting Code, MathWorld. Table of General Binary Codes. An updated version of the tables of bounds for small general binary codes given in Emma Best, A. E. Brewer, F. J. McWilliams, A. M. Odletsko and N. J. A. Sloan, bounds for binary codes of length less than 25, i.e. trans. Inf. TH24, 81 Euro 93A. Table of nonlinear binary codes. Maintained by Simon Litzin, E. M. Raines, and N. J. A. Sloan. Glaser, Anton. Chapter 7 Applications to Computers. History of Binary and Other Non-Decimal Numeration. Tomasz. ISBN A0-938228-00-5 cites some pre-ENIAC milestones.